Welcome everyone. Today we will solve the first problem on ProjectEuler, which is called multiples of 3 or 5. Here's the challenge. If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6 and 9. The sum of these multiples is 23. Find the sum of all the multiples of 3 or 5 below 1000. A straightforward solution is to loop through all the numbers below 1000, check if each number is divisible by 3 or 5 and add it to a running sum. Although this approach works, we can already see that this is inefficient. So let's take a step back and try to describe what we actually want to find here. Suppose we have a set of numbers which are multiples of 3 denoted by blue, and we have another set of numbers which are multiples of 5 denoted by yellow. Then we want to find numbers present in both of these sets and add them up. But if we do it blindly, then it results into some number being added twice, as they are present in both of these sets, such as for example the number 15. The easiest way to solve this is to find the union. That is, get some of the numbers from set blue, add it to some of the numbers from set yellow, and then subtract the sum of all numbers from the intersection of these two sets, which denotes numbers that are multiples of both 3 and 5, that is, multiples of 15. Now that we have a general strategy, let us see how we can build the function. If we think carefully, we can see a pattern. That is, sum of multiples of 5 below 1000 is just the sum of numbers from 1 to 199 multiplied by 5. This last term 199 is just the floor of 999 divided by 5. Now, we know that numbers from 1 to 199 form an arithmetic series with a common difference of 1 between each term. And the sum of an arithmetic series up to the last term, if we know the first term and the last term, is given by number of terms divided by 2 multiplied with the sum of the first term and the last term. In our case, the first term is 1, and because the way in which series is structured, the last term and number of terms are same. Let's call them x. The proof of this formula is pretty easy. You can do it as an exercise or just take a look at resources in the description. Building on this, we can get sum of multiples of 3 as 3 multiplied by x divided by 2 multiplied by 1 plus x, where x in this case would be floor of 999 divided by 3. In general, we can say for a number n, sum of its multiples can be given as shown here, where x is the floor of the division between 999 and n. Great. So we finally have a formula for our approach. Now, let's quickly write the code using Python. We can define a function sum of multiples which takes in two inputs, n and target, where n is the number which we are trying to find multiples of and target is the limit up to which we are trying to find them. So this function will first calculate x, floor of the division of target, and n. And then we just return the overall sum based on our previous formula. Just a side note, in the code we are actually taking the integer division, but the way Python code works, it serves our purpose. In our problem, target is 999. So keeping the value of target same for each function call, we get sum of multiples of 3, 5 and 15 as S3, S5 and S15. And finally, we calculate S3 plus S5 minus S15 to get the solution, which in this case is 233,168. And there we have it. We have solved the problem using a neat little mathematical trick and a few lines of Python code. Thank you for your support to the channel. See you next time.